In this example, we're going to solve this quadratic equation, and we'll do so by using our quadratic formula over here. So we notice our quadratic expression is already on the left side equaling to 0. So let's go ahead and grab our values for a, b, and c. So a is going to be the leading coefficient, which is 1. b is the coefficient of our linear term, so 2 radical 2. And c is our constant, so 7. And now let's go ahead and plug our values into our quadratic formula. So the opposite of b, well, the opposite of 2 times the square root of 2 will be negative 2 radical 2, plus or minus, and then we have this square root. So b squared. Okay, so I want to square this 2 radical 2. Well, I need to square both pieces and then multiply them together. So 2 squared is 4, and the square of the square root of 2 is just 2. So 4 times 2 makes 8, and then minus 4 times a times c, and then times twice a. Okay, so negative 2 radical 2 plus or minus, and then here I'm going to have 8 minus, and 4 times 7 is 28, all over 2. So let's kind of come over here a little. So I have the opposite of 2 radical 2 plus or minus the square root of negative 20 all over 2. Okay, and a couple of things here. We have the square root of negative 20, which can be broken down into the square root of negative 1 times the square root of 20. And when we work this prime factorization for 20 to simplify this radical, we notice it's 2 times 2 times 5. So I have this pair of 2's, which makes a perfect square. So I can factor that, take that out of the radical. So ultimately what I have here is the I with a 2 radical 5. Okay, so let's write it like here. So we have negative 2 radical 2 plus or minus, and we just said 2 times the square root of 5i all over 2. And it looks like every one of these terms has a 2, so let's factor a 2 out. So it's negative times the square root of 2 plus or minus the square root of 5 times I. That's all over 2. So those 2's do indeed cancel. So shuffling up here just a little bit, x equals, looks like the opposite of the square root of 2 plus or minus the square root of 5 times I. And in a lot of cases, we will want to separate this plus or minus because it's complex. We want to write it in a plus bi form. So you could say x equals opposite of radical 2 plus the square root of 5i, and then the opposite of radical 2 minus the square root of 5 times I. Or in a lot of cases, some teachers and students like to put the I before the radical, so there's no confusion as to whether the I is under the radical or outside the radical. So sometimes you'll see it written as plus I radical 5 like that, or minus I radical 5 like that. So either one of those would be acceptable answers for our complex roots written in a plus bi form, given this initial quadratic equation.